Hello everyone. In this video we're going to continue our conversation on hypothesis testing, and in particular we're going to talk about confidence interval. Later in this module we'll be talking about hypothesis test when the standard deviation of population is unknown, which is the sigma, and also we'll be talking about hypothesis test on the proportion. So we're going to be learning about how to construct confidence intervals on the population mean, which is mu, how to choose the appropriate sample size for confidence intervals, and how to use confidence intervals to evaluate hypothesis tests. These are the three main goals. What is the idea behind confidence interval? Well, a lot of time when we try to estimate the population average, population mean, we use the sample mean, right? We take a sample and we use the sample mean to estimate the population mean. Well, we know that that is not perfect, because if you repeat your data collection and you take another sample, X bar is going to change, and that's a different estimation of population mean. So it depends on your sample, your estimation changes. But a better way to estimate the population mean is to provide an interval that contains mu with a high probability, right? Let's give you an example. Let's say that you are estimating the average age of patients in a hospital. Well, the entire population is all of the patients that visit the hospital. And let's say that you don't have access to all of them. So to estimate that average age, you take a sample of patients, let's say 30 patients. And each time that you take a sample, you end up with a different sample average. But what if you provide an interval, you calculate an interval that contains the true average of these patients with a high probability, let's say 95% probability. If you can come out and say, hey, the average age of patients in this hospital is between 45 and 48 with 95% probability. And that's called confidence interval. So the goal is to find that lower limit and upper limit that brackets the true population mean with a high probability. Basically, you want to calculate this L and U, the lower and upper confidence limits, in such a way that the probability of mu between those two values is 1 minus alpha. Well, you probably remember that alpha is probability of type 1 error, and that's the level of significance. Let's say that your alpha is 5%. That means you want to find L and U such a way that the true population mean probability of mu between those two is 1 minus alpha, which is 95%. Some of the assumptions that we have here is that the population is normally distributed, or our sample size is greater than 30. And the population standard deviation is known. Sigma is known. So how do we calculate this L and U? Well, when you have a two-sided test, basically when you have the alternative hypothesis that is mu is not equal to some number, mu naught, the way that you calculate L and U is here in this formula. So this is the L and this is the U, the lower and upper confidence limit. And you're familiar with all of these parameters here. X bar is the sample average, alpha is level of significance, this sigma is standard deviation of the population, and n is your sample size. Well, if it happens that you have a one-sided hypothesis test where the alternative hypothesis is mu more than or less than some value, mu naught, then you might only need one of the confidence limits, either the lower limit or upper limit. Well, in those cases, this is how you calculate it. So you only care about the lower confidence limit, so the upper limit is infinity, or if you only care about the upper limit, the lower limit is negative infinity. And the change that happens here from two-sided to one-sided test is in this z value. This is z of alpha over 2, and this is z of alpha. And the reason is, in a two-sided test, you have these two rejection areas, right? And the sum of those areas are alpha. So alpha over 2 and alpha over 2. But for one-sided tests, you either have the left rejection area or critical region, or the right one, where the area under the curve is alpha. So the z values are the only difference here. We're going to look at some problems in the next video to make this more clear.